Hey everybody, welcome to another math video. So for this one I'll be going over deductive and inductive reasoning. So it's not something you really think about when you think about math, but there's a lot of reasoning going on, so it's important that we cover these things. Okay, so we'll be going over these things here. Pretty straightforward. Okay, so first off, deductive reasoning. The easiest way I can explain this is with this little bullet point here. If A equals B and B equals C, then A equals C. So it's kind of like if this is equal to that, that is equal to other that, then this is equal to other that too. So basically, when you're using deductive reasoning, you're using evidence to come to some kind of a conclusion. Okay, so let's take a look at an example of this here. So Sagwa is a cat. Cats have really good smelling abilities. So based on these two things, I can assume Sagwa has really good smelling abilities. Okay, so all things being true, so the first two statements being true, then you can come to the conclusion that the first thing and the second thing are related somehow. Okay, so let's take a look at another one. So the Shetland is a horse. Horses have manes. The Shetland has a mane. Okay, so it doesn't get any more straightforward than that. So using evidence to come to some kind of conclusion, right? So the first two statements are your evidence, and you're using the evidence to make a conclusion out of those two things. Okay. So next is inductive reasoning. So inductive reasoning is a little bit more difficult. It starts with something. It starts with a statement about something a little bit more specific, and you use that statement to create a broad generalization. Okay, so what does that look like? Let's take a look. Okay, so there's a bag of coins on the table. David pulls out 10 coins, all of which have been dimes. So the bag must be full of dimes. So that's pretty. You see how it's specific here, specific here. So we generalize, right? Because David pulled out coins and all of them have been dimes. So we think, oh, the bag must be full of dimes. Okay, so let's take a look at another instance here. So Maria always leaves her work at 7 a.m. Maria is never late. So Maria assumes if she leaves for work at 7 a.m. today, she will not be late. Okay, so that's, I know what you're thinking, that's kind of like, sounds like deductive reasoning to me, but it's kind of not, because this is a specific instance. This is a little bit more general, and this is actually a more general statement than it is coming to a conclusion, because it's not so much as you're looking at evidence, it's so much observational type of things, right? As opposed to the deductive reasoning where you're looking at pieces of evidence. So think of inductive reasoning as you're looking at more observational kind of things, right? So same thing with the first example here. These are observations, right? We observe David pulling out 10 coins and we observe them to all be dimes. So we come to the general conclusion, or I should say general assumption, that the bag must be all dimes. Whereas here, right, we observe Maria always leaves at this time. We observe that she's never late. So in general, if she leaves at this time, she won't be late. Right? So I know it gets a little bit muddy there, but just remember for deductive reasoning, we're using evidence, right? Whereas in inductive reasoning, we're using observations. Okay, guys. Well, that's pretty much it for this video. Thanks for tuning in. And I know this is a it doesn't seem like it's a really math topic, but and I kind of agree a little bit. It's more logic and logical reasoning, but we use logic and logical reasoning in math, so it's important that we go over these things because it's kind of the setup for doing proofs and all the the steps in algebra that we use. Okay guys, so that's it for this one, and thanks for tuning in, and check out my next video coming out soon.